All right, so today we're going over Module 2, Factoring and Quadratics. And this is the first problem we're going to look at right here. What we should notice is that each of the terms here are divisible by 2. So we can factor the 2 out of that. So what we do is we say, all right, 2 times what is equal to 2x squared? Well, 2 times x squared is equal to 2x squared. And then 2 times what is equal to negative 10x? Negative 5x. And 2 times what is equal to 12? And that will be 6. So that is the first step in factoring completely. Now we're going to factor by parts, and in order to do that, what we're going to look at is we're going to say there's a 1 in front of that x squared, and I'm looking at this 6 right here. So what I do is I do 1 times 6, and that equals 6. Now we're going to break this middle term into 2 pieces, and the 2 pieces have to multiply together to give me 6 and add together to give me negative 5. Well, the only way that they can add to a negative and multiply to a positive is if they're both negative. Okay? So the first thing I'm going to start making a list. If we have negative 1 times negative 6, that equals 6. But does it add together to give me negative 5? No. It's negative 7 when we add. And then we have negative 2 times negative 3 is 6. Is negative 2 plus negative 3 negative 5? Yes. So we've found the way to break apart our middle term there. So we have a negative 2 and we have a negative 3 that we're going to break our negative 5 into. So now we have 2 times the quantity, x squared, and then minus 2x minus 3x, and then our plus 6. If we didn't have another one, we would have tried negative 3. Like, let's say it didn't work right here. We would have tried negative 3 and then negative 4 and gone on. So that's the way we go through that process. If you don't see right away that the 2 numbers I can break this apart into are negative 2 and negative 3, then you just go through them until you find the ones that work. Now, I'm going to take this part and factor it, and this part and factor it. This is called factoring by grouping. So we have 2 times the quantity. Now this, we can factor out an x. X squared is divisible by x, and negative 2x is divisible by x. So we're factoring out an x. And then it's going to be, so x times what is x squared? X times x is x squared. X times what is negative 2x? That's negative 2. So I've factored this part right here. Is that step okay, or do you want to ask a question? Okay, all right. So now we're going to factor this part right here, and both of those are divisible by negative 3. So negative 3 is divisible by negative 3, and positive 6 is divisible by negative 3. So I'm going to factor out a negative 3. And when I do negative 3 times something, it has to equal negative 3x. Well, it's going to be x. And negative 3 times something is a positive 6, and that's a negative 2. And now, so these parentheses here are saying I'm multiplying everything inside by 2, just like I was up here. So it's important to have those parentheses there. So the other thing that's really important to see is that I have this factor, x minus 2. It's a binomial, and it's a factor here, and it's a factor there. So this next step is factoring that out of each of those parts. So we have 2 times the quantity x minus 2, and then I need to put in parentheses x minus 2, that quantity, times what is this? Well, times x. We can see it right there. X minus 2 times what is equal to this? Well, negative 3. I can see it right there. And so that is the solution for that problem, factored completely. That's it. Yeah. So I'm going to go through, there'll be more problems and maybe some more difficult, but that's the most basic kind of thing that you'd expect to see. You'll definitely see something like that on the DBA. Okay. The next one, let's do 64x squared minus 9. Now, this one is a special kind of a problem. It's called a difference of squares. And that means that this is a square and this is a square. Now, can you look at those and tell that they're squares, or can you not see it? And do you know what I mean by squares? Yeah, okay. So what I want you to see is that this number 64 could be rewritten as 8 squared. X squared is already a square. A square means, we're talking about like the area of a square is the way to think about it. Which, remember, the area of a square is length times width. But length and width are the same. So really it's just the length squared. So anytime we're squaring a number, particularly a whole number, it's a square. And then this 9, how could it be rewritten as a square? Three squared. All right. So now we're gonna rewrite this side as 8x squared and 3 squared. So now look, it's a difference of squares. And that's why this kind of a problem is called a difference of squares. And it turns out that when we actually have a difference of squares, there's an easy way that it factors, and that is like this. Whatever is squared here is the first term in the two binomials, binomial 1, binomial 2. And whatever squared here is the second term in the binomials. And one of the binomials has addition and one has subtraction. So this is how we factor a difference of squares. Now, if you look at this problem and you notice that it is a difference of squares, then you could rewrite it like that immediately, and I would be perfectly fine with that. Okay? And, you know, there might be an easier kind of a problem that you would notice as a difference of squares. Maybe that you'd notice is a difference of squares because 4 is 2 squared. And so you'd rewrite it as the quantity x plus 2 times the quantity x minus 2. Does that make sense? Yeah. So that's a difference of squares. Now, strictly speaking, you could use the same process we used up here, where you take the 64 and the negative 9 and you multiply those together and get something, but it gets really complicated. So if you understand this pattern in difference of squares, it's much easier, much easier. Okay. All right, so let's look at a, okay, so we're going to look at a kind of a problem that's a little bit more complicated here. It's also going to be a factoring problem, but it's going to be, it's going to have more than one variable in it, all right? So we're going to have like two variables, and we're going to factor it. All right, so if we have something like 3ab minus a plus 18b squared minus 6b. All right, so now in this one, it's set up nicely so that here we can factor something and here we can factor something. So just like before, we're in a situation similar to right here, where here we factored this, here we factored that, and then that allows us to finish. So we're in a similar kind of a situation. Here we're going to find a factor, here we're going to find a factor, and then we'll finish it. So what I see is that a can be factored out of both of those terms. So I'm going to have a times the quantity. A times what is 3ab? 3b. A times what is negative a? Negative 1. So right here, I rewrote there. Now we're going to factor here, and I see that 6b, 6 is a factor of 18 and 6, and b is a factor of b squared and b. So I'm going to do plus 6b times the quantity. 6b times what is positive 18b squared? Positive 3b. Positive 6b times what is negative 6b? Negative 1. And now we can see that this we got from here. Okay? Now we should see that we have that 3b minus 1 as a factor of both of those terms. So we factor that out. We have 3b minus 1. So 3, and the other factor up here is the a. And so we have times the quantity a. And 3b minus 1 times what? Well, the other factor up here was 6b. So plus 6b, and that is our answer. How's that? That's the answer. It's just factored, yep. Yep, it's just a factor. I'm glad to hear that you're feeling like those are easy. Well, let's just keep going through a few more. Do you want to see another one like that, or is that good for those? Okay, all right, great. So now I'm going to talk about graphing quadratics, okay? Quadratics are equations that have an x squared in them. So if we have y equals, let's start with x plus 3. That quantity is going to be squared. And then we're going to do minus 4. Now, this is written in vertex form. And vertex form is a great form for graphing. It's really nice. But the general form is a times the quantity x minus h squared plus k. And the vertex itself is the point hk. So whatever this number is right here, h, will be the x value of the vertex. And whatever is this number here, the k, will be the y value of the vertex. And then the other thing that we have is we have that A value, and the A value is, it tells us the stretch factor. And so the idea is that the parent graph looks like this, and let's just say it looks like this. And if A is greater than 1, it stretches up this way and gets skinnier. And if A is less than 1, it flattens out this way and gets kind of wider. Okay, so A greater than 1 stretch, A less than 1 gets wider. If A is greater than 0, that is A is positive, then we have what looks like a smile. And if A is less than 0, or it's negative, then the parabola is going to be like a frown. And what you should notice also is that in either case, this point right here that is either the lowest point on the graph, or this point right here that is the highest point on the graph, in either case, that is our H and our K, because that is the vertex. That's where the vertex lives on the graph, the highest or the lowest point. Okay, so far so good? Okay, good. All right, so now we can look at this particular problem right here, and we can see right here, that's our H part, and right here, that's our K part. But notice over here in the general form, it's X minus H, but we have X plus a number. How could we change that to be X minus some number? What would that have to be? X minus? Well, it would be X minus a negative 3. Because we can always change addition to subtracting a negative. Does that make sense? Okay. And then that's still going to be squared. And then we have minus 4. You know what? I shouldn't have made that yellow. I'm going to make this now blue, because that is our H. And I'm going to have this outline saying that's where it came from. It came from the 3 above, but the negative 3 is our H. And this is the same out here. Instead of subtracting, we're adding a negative 4. So that means that our K is a negative 4. So we have our HK, so the vertex is the point, negative 3, negative 4. Now, you may look up front here and say, hey, we need an A value there. Well, we do have an A value. I don't want it in orange, sorry. Our A value is a 1. So when there's nothing written there, there's kind of like an unwritten 1. Okay? So if we're going to graph this, just do a quick sketch of the graph. Then our vertex is at negative 3, negative 4. Negative 1, 2, 3. Negative 1, 2, 3, 4. Right there is our vertex. And that's going to be negative 3, negative 4. And the A value of 1 is positive, which means our graph's going to go like that. And it's a 0 stretch. It's the standard curvature. So when we move to the right and the left 1 unit from the vertex, we just go up 1. So there's going to be points on the graph right there. And really, what you can think of it as is 1 squared. 1 squared equals 1. So when we move to the right and the left 1, we go up 1. And then when we move to the right and the left 2, we think of 2 squared. 2 squared is 4. So we go up 4 to right there. And this is depending on what our A value is. And then when we go to the right and the left 3 from our vertex, 3 squared is 9, so we go up 9. Well, let's see, it's going to be right up here and here. And so then I can just connect those like that. And there is our parabola. So if I want to see where that A shows up on the graph, I can zoom in here and I can put going left 1 unit means going up 1, going right 1 unit means going up 1, and that's our first points away from the parabola. Questions on graphing using vertex form like that? Uneven. What does uneven mean? The -3 there? Oh, the vertex here? Or here? Yeah? It would go right here. So it is perfectly symmetric. This is called the axis of symmetry right here. And it's always x equals h. So in this case, x equals -3 is the axis of symmetry. And so if it looks like it's not symmetric, that's just me not doing a good job. Yeah. Thank you. Yeah, important. Would you like to see another one like that? Okay, great. All right. Okay. So let's start with y equals, that's up a little bit high there. Y equals, let's do -2 times the quantity x minus 1 squared plus 3. All right, can you tell me what the vertex would be? Remember it's let me bring this over. I used the wrong colors, but copy that. Well, actually, I'll copy all this. Whoops. There you go. All right. So let me get the colors to make sure they're right. It should be orange. Well, so the vertex is just 1, 3. Yeah, good. All right, and the A value there is -2. Okay, so if we're thinking about graphing, I'm just sketching kind of quick graphs. 1, 3 is right there. And I knew that I needed to have all this space down here because my A value is negative, which means it's going to open down. It's going to be like this because A is negative. And because a is negative 2, when I move to the right and the left 1 unit, I think, well, negative 2 squared, or I think 2 squared is 4, so I'm going down 4 units right there. And down 4 right there. So that's going to be where my next points are. Does that make sense? Like why I'm saying that? Yeah. So when we move, it gets complicated. So the way we think of it is we think of left and the right, 1 unit, and 1 squared is actually 1 times negative 2. Oh, I messed it up, my friend. You should have said, no, Mr. Whitewolf, that's not right. That's not right. What are you doing? What are you thinking? I just totally said something wrong. When we move right and left 1 unit, we think 1 squared is 1 times negative 2 is negative 2, right there. So we do the 1 squared still, and then multiply the result by a. And then we do to the right and the left 2, and we do 2 squared is 4. 4 times negative 2 is negative 8. So when we go right and the left 1, we go down 8. There. And there. So do you see what I'm saying? Right and the left 1. 1 squared is 1 times negative 2 is down 2, negative 2. Right and the left 2. 2 squared is 4 times a is down 8. Because 4 times negative 2 is negative 8. Mostly you won't be dealing with a values like that. You'll probably have a values of 1. But just keep it in mind. Questions on that one? Okay. All right. If we look at this and I say, hey, what's the average rate of change from x equals, oh my gosh. You should have said, Mr. Whitewolf, you are messing this whole thing up. I'm just looking at this, Autumn, and I messed it completely up. This is 1, 3. Where did I put it? It's 3, 1 is where I put it. Right? Do you see that? But luckily, I'm using electronic information, and I can just move it like that. But still, that's not good. All right. Anyone out there watching, I hope you caught it. Do you see there what I'm saying now? Okay. Oh my goodness. All right. What's the average rate of change from x equals 1 to x equals 3? So what I want to ask here then is, looking at this point right here, x equals 1, and this point down here, x equals 3, what's the average rate of change? Well, to calculate average rate of change, it's really just like the slope formula, okay, between those 2 points. So it's saying if we drew a line straight through those 2 points, what would the slope of that line be? That's really what it's saying. So the slope formula then, well, we have our first point up there is 1, 3. That's our green point here. And our other point there, the pink slope, or the pink point, is 3, and it's a negative 1, 2, 3, 4, 5, negative 5, 3, negative 5. So those are our 2 points that we're going to be working with. And the formula for slope is x1 minus x2 over y1 minus y2. And you can decide that your point 1 is the green one and point 2 is the pink one, or you could decide that this one is pink and this one's green. It doesn't matter which one, you'll come out with the same solution. Okay, so to do this calculation then, we do the x value in our pink point is 3, minus the x value in our green point is 1, over the y value in our pink point is negative 5, minus the y value in our green point is 3. And now I can just look at that and say, all right, 3 minus 1, that's 2. Negative 5 minus 3 is negative 8. And, oh my gosh, Autumn, someone should just stop me and tell me to go back to school, because I am messing all this up, my friend. And I've said your name a couple times on this here. I hope that you don't mind. Sorry. You want me to bleep it out? It's y1 minus y2. Rise over run. x1 minus x2. This is not good. You ever have a teacher mess up this many times? Don't answer that. Yeah? All right. All right. y1 is negative 5 minus y2 is 3 over x1 is 3 minus x2 is 1, and that's going to be negative 8 over 2, which is negative 4, or negative 4 over 1. So I knew that I had made a mistake because I was going to get a slope of negative 1/4, which is pretty flat. But this slope needs to be steep, and negative 4 is much steeper. So I knew I had made a mistake, and that's how I caught myself. Using that equation, do you feel comfortable using an equation like that? No? So, thank you. So, do you see, if I give you this equation, and I say, these are the 2 points we're talking about, and you write down, all right, well, here's this point, it's 3, negative 5. Do you see how I know that's 3, negative 5? Oh, so from the origin, I go to the right 3 and down 2, 3, 4, 5. So it's 3, negative 5. That's just the coordinate point. That's how we name it, with XY coordinate. And this one is 1, 3 because I go to the right 1 and up 3. Okay? So, when it comes to the coordinate points, the coordinate pairs, remember they are x, y coordinate pairs. Left, right, up, down. Okay? So now you see where these come from, right? Okay. Now we have this equation, which you should definitely have in your notes, that equation. And so remembering that these are XY coordinate pairs, I've decided to call this X1, Y1, and this X2, Y2. Now I could have switched these and called this X1, Y1 and this X2, Y2. It doesn't matter. But I just chose to do it this way. So here for y1, I plug in my y1, negative 5, minus my y2 is 3, divided by x1 is 3, so my x1 there, and then minus my x2 is 1 right there. So now, could you get this from your points if you have this equation? Okay, all right. And then you just need to do negative 5 minus 3 is negative 8. And 3 minus 1 is 2, which is equal to negative 4. Okay? Okay. So we still have about 20 minutes left, a little over 20 minutes. I'm going to stop here for a moment and start recording a new video.